Hello, can you hear me? Okay, great. So this is kind of like, so most of my talks are me procrastinating, I'm not gonna lie. And this was basically born out of my frustration at some point. So this is the evolutionary saga of Python packaging. And I'm Nafiul, I'm a developer advocate at Sonar. We are basically the creators of a static analysis tool that analyzes your code for any kinds of bugs, security vulnerabilities, and things like that. And it even works in Jupyter notebooks. So we have Sonar Lint that works with VS Code. So please try it out. It's completely free and will be free for pretty much ever, I think. A warning about this talk, because I know that packaging elicits a lot of emotions in people. And, and this talk is from the perspective of a user. So it's not that I don't care about the people who are doing the packaging, it's just that I don't care for this talk about the people who are doing the packaging. Anyways, so down the rabbit hole, why are we here? So I needed to install a package on Windows, as one does. Oh yeah, we're going there. And unfortunately, the package wasn't installed. But don't worry, it gave me a really good error message as to why it wasn't installed, okay? And it told me that Visual C++ 14 wasn't installed. Now that's a good error message, wouldn't you agree, folks? Right? Like it's telling you what to do. But then, when you try to install C++ 14, you get an unspecified error of unknown origin. Great stuff, eh? And this reminded me of the time in the good old days where there was like this professor at, the University of California, Irvine, who'd package pretty much every single scientific Python library out there, and you could download it as an exe file. This is how I discovered and used SymPy to cheat on my calculus exams. This is how this is how it was done back in the day, okay? And God bless this man, honestly. This man has helped me ace so many exams. And so at this point in time, I was like, all right, we know that Windows is broken. And Microsoft knows Windows is broken. So we can use Windows subsystem for Linux, right? I mean, like, they've thrown in the towel, why not just use the towel? And then you don't have enough permissions to install the package on Windows subsystem for Linux. And you know what? I use an Ubuntu LTS, okay? So don't come at me, be like, oh, you didn't install it right. I did, okay? I did. And so at this point in time, I was a little frustrated. And so why does it have to be this hard? And to answer that question, my friends, we must ask, what is a package? A package is effectively someone else's code that you can use, okay? You're just taking somebody else's hard work, not paying, you're basically using somebody else's stuff. Okay, great. So this means that that said stuff or code needs to be compatible with your version of Python and the operating system that you're using, okay? But, you're gonna say, hang on a second, Python runs on everything, right? ARM, Intel, all that good stuff, right? Well, buckle up, my friends. We're going to start out with the very first way that Python packages were managed. This was copying and pasting stuff. Somebody would email you a tarball, you figure out how to install it somewhere, and so in one sense, you are the package manager. But at some point in time, the folks over in Python land decided, you know what, this might not be a good idea. All this copying and pasting, and also Christoph is getting a lot of email that his stuff doesn't work. So anyways, they decided to create the Vaults of Parnassus. And the Vaults of Parnassus were named after Mount Parnassus. So apparently Apollo lived on this mountain, like, the Greek god who'd throw arrows around and stuff, and was a god of music and stuff. So basically he had these vaults on these mountains, and these vaults in these mountains would contain untold works of art and stuff like that. So lots of paintings and sculptures and other stuff that, Greek gods have. And that was kind of like the idea behind Python packaging. Like we have these packages that are works of art, that are awesome in that sense. And this is what the Vaults of Parnassus looked like. And way back when, and this is old because like the download link is from SourceForge. People who got that are old. Anyway, so anyways, this is what it looked like. It had all different kinds of metadata. It would tell you what platform it would work on, what kind of GUI it used, and of course you could download these projects. And of course these links were to external repositories, so they weren't exactly centralized repositories. And of course, it would tell you stuff like what kind of platform it worked on. So here you have Linux. It's got license also on SourceForge, so you know it's old. And that's kind of how things were in the vaults of Parnassus time. So it would tell you what kind of operating systems it would work at. So there was this package a long time ago called IDE Studio. I didn't know this, but like there was a full-fledged IDE for Python written in Python all the way back in, I don't know, the before 2000s. And you might ask yourself, we have Google, don't we? Like, why can't we just search for this stuff up? It's like, no, you don't. It's 1996. Google came out in 1996. And so, of course, it had very helpful tags about what places you could install this stuff. So, like, you have Win32. Back then, Windows 95 was still kind of new, okay? It was the first 32-bit Windows. Before that, it was a 16-bit Windows, so Win32 had to be specified. But also, you had very helpful, and I do mean very helpful classifiers like Win32 and possibly Linux. And back then, the Vaults of Parnassus, and this is in 2007, got 450,000 to 500,000 visits in total per month, okay? I think PyPI does that in a couple of hours. Not even probably in a few minutes, I don't know. I mean, it's got 80 terabytes of data.
300 million a day.
Oh, really? Yeah, she knows. She's dead, by the way. Ask her difficult Python packaging questions. So the pros was you had a centralized place to share the Python packages. It's better than email attachments. You have freedom for repository owners to define whatever, and I do mean whatever, their packages were. And the cons were it's not automated, means of packaging wasn't standardized. I mean, at this point in time, you're throwing out zips, tarballs, and any other kinds of zipping stuff that I don't know about, honestly. So you steal are the package manager. So in 2000, we came out with disutils. And disutils was really the first attempt at standardizing Python packaging, and it came around Python 2.0. And this is effectively what it did. It said, like, all right, listen, we're adults now, okay? These are the fields that you need to have, and this is how the directory structure should work. Most of the important stuff is in package info, okay? We good? Great, that's a package. But a package could have more than source code. It could have binaries. And so at this point in time, we need to take an intermission. We need to talk about Python. We got to come clean about what we've done. And so Python is the most successful glue programming language in the world. What that effectively means is that whenever there's a compiled language that comes around that's really fast and nice and shiny, we go, ooh, shiny, let me take some of your code and integrate it into Python. As long as that compiled language has a C foreign function interface, we want it. But that has consequences, right? You can't just go around taking other people's code and not take their problems as well. So let's talk about what problems we're talking about. So here you have the source code. You have both Python source code and you have source code in C++, Rust, Python, Fortran, Carbon. I was talking to some guy yesterday. He was like, hey, I managed to pack in CUDA as well. I'm like, oh God. Anyways, so you got to compile all of that, right? And this is what a person compiling all of that looks like. This is a true depiction. And we've been doing this for a long time. NumPy's predecessor, Numeric, used BLAST and LePack libraries. So these are linear algebra libraries from Fortran. You know, some person probably in this audience went out there and said like, ooh, I like this Fortran stuff, but I want Python bindings. And that's what they went and did. And then we have NumPy. And we've been doing this, like Robin, which is a new Python framework built on top of Rust, uses Tokyo, which is an asynchronous runtime written in Rust. So we've been doing it for a long time, and you know what? We're good at it. And so you don't just have Python's packaging problems. You have every language's packaging and build problems, okay? So Python's unique abilities are a double-edged sword. So anyways, back to disutils, now that I've dropped that bomb on you. where was I? Distutils. So distutils recognized this, and so it helpfully added two types of distributions, two types of ways that you can have packages. One was the sdist, or the source distribution, and the bdist, or the binary distribution. And most of the time, binary distributions worked on Linux systems pretty well, right? But on Windows and Mac, it didn't work so well in the beginning, but then Mac caught up with Homebrew and Mac ports. But Windows, unfortunately, was left out, and in a way is still left out. I'm just not gonna, look, I'm here to tell you the truth, okay? It's not good over there, even with WSO. So distutils, if you think about it, Python is slowly evolving, right? It's growing up. Like, people used to use packages from somebody that was working 2 tables down that way, and now they were emailing things around to people all over the world, and at this point in time, they were like, hey, listen, we gotta be adults, so they made distutils to standardize packaging. But they didn't think about everything. They didn't think about dependency management. Why would they? They're like, hey, one package is all you need, right? Yeah? You don't need to version stuff, right? You don't need standardized distribution formats, whatever those are, right? Because they weren't in scope. So you're still package manager. So in 2004, we come up with the Python package index. And this is basically the vaults of Parnassus getting a facelift, because we're still connecting to external repositories, still SourceForge. Maybe a little bit of GitHub's getting in, but like it's still SourceForge. And only all the way later, I think in 2014 with Project Warehouse, and thanks to Fastly, we kind of centralized all of this. So honestly, thank you, Fastly. But at this point in time, it's still very much, hey, let's just patch this thing together. But if you can see, it's Python powered. So it still had hard links to external repositories. So at this point in time, 2004, I would say the biggest change in Python packaging came about, and that was with the introduction of setup tools. Now, I know a lot of people have issues when I say the word setup tools. I don't care. Because setup tools had the kind of impact on Python package management that WSGI had in web development. It completely transformed the way that Python packaging was done, and it was completely revolutionary for its time. And so this is what a distutils setup.py looked like. Say it's not much, you know, you got your name, you got your version, you got packages and some other information that you probably don't care about. But setup tools are like, no, we need more information. And one of the first things it did is that it allowed you to declare dependencies. Because a lot of the times, you know, Python is growing up, right? Packages depend on other packages. At this point in time, you were able to declare your dependencies, and you were also able to figure out what packages you had installed in the first place using the find packages method. Yes, we didn't have this up till now. And of course, you also have entry points coming in from setup tools. So for example, when you run pip, when you run virtual env, when you run all this command line stuff and all this command line gobbledygook, right? That's setup tools did it, not me, setup tools. And of course, you also had richer metadata. So you are constantly evolving Python packaging, but I guess this also kind of came to a head with the egg format. Now, the egg format was basically a zip file that contained the contents of a Python package. But you might say, like, hey, we already had zip files, right? So what's the big deal? Well, distutils produced 2 types of packages, right? Source and binary distributions. Well, eggs could do both. And so this is what, you know, merging those 2 formats looked like, real fusion. And it also introduced more kinds of binary packages. So it turns out there are lots of ways of doing binary, right? So like, it introduced bdist_win install, so for Windows, and of course it also introduced bdist_rpm for Linux, and RPM stands for the Red Hat Package Manager. So when people say that Pythonistas didn't care about Windows, this is not true. We sort of cared about Windows, always. And this was the first set of tools, introduced the first automated tool that allowed you to install packages from the newly created PyPI, and this was called Easy Install. It wasn't really that easy to install packages with Easy Install, but it was something, right? Like, come on, people. So overall, setup tools provided a better way to package things, added a better binary distribution management system, came in with Easy Install, added better dependency management, well, actually added dependency management. It wasn't like better dependency management. added more classifiers and added entry points. Okay, great. So we're growing up. Python's growing up. We can do more things with packages. More things can go wrong. But you couldn't install packages. Uninstall them. Yeah. So in a way, this actually, and it had issues with dependency management, right? So how many of you have used LXML? Some of you. How many of you have scraped a website? All of you. Great. That's because you've used LXML. So LXML had a lot of dependencies because in order to scrape all that HTML, which is kind of like an outgrowth of XML, if you will, and it required a lot of really fast libraries that needed to be compiled, and eggs really weren't everything that it wanted. Easy install couldn't verify package integrity or authenticity. Now, we're slowly creeping into the issues that you have with scale because as you get bigger, some bad people come along and want to inject malware into your packages. This happens every day. I know it's sad, but it's true. So you're still the package manager. The next big thing that happened, I would say, is virtual env. Now, this isn't exactly about managing packages, but it's about managing Pythons, which we quickly needed to do because we need to isolate these Python environments because it's just getting too big. Every package has transitive dependencies, which is dependencies of dependencies. And so it wasn't all that great, and we didn't want to clutter our main Python installation. So virtual env was born. And it was a really good thing that it was born, fellas, because but Python 3.0 was released in 2008. Virtual env came out in 2007. Now imagine having to deal with the Python 2 world and the Python 3 world without virtual env. Just imagine, not great. And virtual env became standardized in 2011 under PEP 405. So eventually, the folks over at the steering council realized, this is a good idea. And so we come to pip. How many of you use pip? Oh, come on, you use pip over there as well, I know. Pip was the successor to easy install, and it's something that we still use today. And easy install tried to install packages one by one, but pip was able to get a list of packages that you have, kind of flatten that list of all the packages that you need, and then just boop, install those packages, still one by one. And pip had the ability, guess what, to uninstall packages from your site packages, right? So that is a feature that we've been waiting for a long time. It came up with requirements.txt for the first time. And of course, pip enforced secure connections to PyPI, reducing man-in-the-middle attacks. So you're slowly seeing Python go from shooting out tarballs to shooting out zips to shooting out eggs, and now starting to care about security. We're slowly growing up as a community. But binary distributions still needed to be improved. I'll tell you why. Because we came up with wheels. And this time, the folks over at Python made a pinky promise. It's like, look, this is the last time we're going to reinvent the Python packaging format. So we're going to call it wheel so that we don't reinvent the wheel. Get it? And of course, there was an abstract, but basically what it says is like, look, we need a better format, and that's what the abstract says. And so I want to show you. So if you install NumPy today, right, you're going to see that it has a separate metadata, right? But it's also going to have which version of C it's using, which version of the operating system, which version of the operating system, and of course, under what architecture of the operating system. Because think about it, Mac has Intel, there's Intel Mac, heck, there's even Intel Windows, there's ARM Mac, there's ARM Windows. I mean, way back when you had PowerPC Mac, like there are a lot of ways that you can install Mac and operating systems on the different architectures, and they affect the way your binaries are compiled. So it's not always great. So it had even better support for binary distributions. So, I thought like, hey, we got wheels now, right? Like this is great. So we should be able to install everything on all operating systems, and it's all good and we're all happy. We're all singing Kumbaya. So I tried to install this package that pretty much everything depends on. And then I got this error telling me to install Visual C++ 14.0. And so I got an unspecified error of unknown origin. So anyways, some folks over, I think at that time, was it Nthought or Continuum Analytics, which eventually became Conda, Anaconda, they were like, we got to fix this problem. We really do, because like, we somehow managed to get all these scientists into the Python community, and they keep complaining about packaging, And so just to give you a little bit of a 101, so you have your operating system, right? You got your Windows, your Ubuntu, your Mac, and then you have your package manager. So you have your Winget, your Chocolatey, your Pacman, your Homebrew, and if you've never heard of Winget or Chocolatey, that's because those are Windows package managers, and they're bad. And of course, you have your applications, and on top of that, you have your application package manager. I couldn't find a logo for pip, so I just kind of screenshotted pip. So Conda was like, you know what, we're not having pip problems. We're gonna have real package management problems, and we're gonna work just under the operating system. So Conda is not just a Python package manager. It's a package manager like Brew, like apt, like Yum, and it's a cross-platform package manager. I gotta be honest with you, that is impressive. And so to create a Conda package, there's just a lot more scrutiny, because Conda packages contain precompiled binaries for every platform. And I do mean every platform. It's very hard to create a Conda package. They'll tell you otherwise, but it actually is quite difficult. And you never need to compile anything. This is why people in the scientific community love Conda, right? How many of you use Conda? How many of you use Windows? Wow, you still use Conda instead of, okay, great, okay. So Conda is not limited to Python packages, but can also install R packages, entire applications. So you can install Jupyter, you can install PyCharm, you can install Dataspell, VS Code, whatever you like, you can actually install it. And Conda also had the ability, because it came up after virtual env, to install isolated environments. But there is a problem. And the problem is, like, for example, if I were to try and install Maturin, how many of you used something that uses Rust? How many of you use Polars, for example? Some use Polars. So that's what they use to build Polars. It's called Maturin. A really nice gentleman called David Hewitt makes this. And you can see that on Conda, it's version 1.3.1, okay? The latest version is 1.6.0. And now some of you are going to tell me, oh, you didn't update your index. You're using the, no. I updated everything. So I'm going to tell you this. Conda is by far the best tool to install Python packages on Windows. But if you want the latest and greatest, unfortunately, you're still going to have to use something else. So around 2017, we got something called pepenv. And, virtual env became best practice. So I think the creator of pepenv, who you might know as the creator of requests, Kenneth Wright, so it's like, hey, maybe it would be a good idea to combine these two. He doesn't actually talk like that, but I just did it for a fact. Don't kill me, Kenneth. So basically what it did is it was like, okay, so we got the virtual env and pip together, but like also requirements.txt kind of sucks. Oh, did I just say that? Okay. It's not that great, it's not adequate. And so we had this new thing called a pip file, and pip file had your sources, your packages, you could specify what dev packages you had, et cetera, et cetera. So it was kind of like an evolution because, again, Python is growing up. And of course, it had the pipfile.lock that allows you to create reproducible environments. And of course, it also had a graph that tells you what your transitive dependencies are. So not just your dependencies, but what the dependencies of your dependencies, like your second cousins. Oh, wait. And of course, it also did some security scanning to tell you if you installed any packages with vulnerabilities, right? So, Python is expanding its scope of what it cares about in terms of packaging. And so in 2018, we got poetry. But before we get to poetry, we got to talk about PEP 518 and 566. So when the folks over at Python Packaging looked at pipfile, they were like, hey, this is a great idea. Let's standardize this thing. And that's how you got pyproject.toml. And what pyproject.toml does is that allows you to kind of replace both the setup.py and sort of requirements.txt, although I would say that it's still a little bit overkill. But yeah, so what packages you need are also becoming more standardized. So back to poetry. Poetry added support for pyproject.toml. I've been told that it doesn't have perfect support for pyproject.toml, but it has a good enough support for pyproject.toml. And you could also publish directly your packages using Poetry. So as you can see, things are slowly starting to get more standardized. Things are becoming easier. You don't have like disparate tools. Of course, some of you are going to ask me about PDM, which is the Python Dependency Manager. And PDM is effectively, at this point in time, is basically Poetry, with a little bit of better support for PyProject.toml, because it is completely PEP compliant. But really, it was designed for 5.8.2. And 5.8.2 was effectively PyPackages, which was kind of like creating node modules for Python, but unfortunately it got rejected. And so we're not going to have that anymore. So really, there's not much difference between PDM and Poetry at this point in time. But there is one thing that you can do with PDM, which is that you can convert a pip file into a PyProject.toml file using Poetry. So if you want, and I would recommend, like if you start off with a small project, what I usually do is that I usually start with pipenv, right? I use pip file, install all my stuff, mess around a little bit, and then when I want to be a grown-up and want to package this up, I get PDM involved or Poetry involved, whatever you like, and I transform it into a package. So that's one use case for it. 2023, we got UV. And UV is an interesting library. It is a package manager that does nothing new. It just re-implements everything that pip and other tools do using Rust. So it literally reinvents the wheel. And it aims to be the cargo of Python. Well, you got to have big goals. And of course, it's very fast because Rust, right? And it's being actively worked on. So it has 354 open issues, and it already closed 1,335. So it's actively being worked on. There are lots of things that it needs to fix and resolve and stuff like that. But it's still really too early to pass judgment on UV. You're not going to get me to say it's completely useless. But it's still working. There's still work that needs to be done on top of it. But it has big ambitions. So, to take it away, it's the binary, stupid. That's why we have problems with packages in Python. That's why we'll always have problems with packages in Python. Python is basically the language that goes around, looks at a compiled language, sees, oh, I like that package, looks for a C-form function interface, and then implements bindings. That's what we do. And Python packaging, frankly, has improved leaps and bounds over the last 2 decades. People constantly say, oh, it's terrible, it doesn't work. It's like, yeah, but did you see what it used to be like? In Python, dependency resolution is still difficult. That's why we can't have node modules. So just to give you an example, if you have library A and library B, they both depend on library C, but library A requires a different version of library C compared to library B, you're going to have an issue. Node does not have this issue because every module has submodules, and when you work with code inside of that module, it only uses the submodules. It doesn't go into the global scope. Whereas in Python, when you install a package, it just goes all into side packages. So we can't have cargo because we have many language dependencies. Rust has a dependency on Rust and some C, and that's kind of it. So if you got packaging problems, I feel sorry for your son. Python packaging will always have problems associated with binaries, but Python packaging continues to improve and expand all the time. The latest thing in question is PyIodide, where you can right now compile Python to work on WebAssembly. So in Python land, we ask not what problems we can fix, but rather what problems we can acquire. And this is a conclusion that was come to at EuroPython 2023 at the WebAssembly Summit, is that the only conclusion we can reach when it comes to Python packaging is that there is no conclusion. And this is called the Lemberg paradox, coined by Marc-André Lemberg, who's a C-Python core developer. So you can definitely ask him more questions. So from time to time, you'll still see an unspecified error of unknown origin. Still, thank you.